Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little's Law YouTube channel. And this is me, your Shanmugam. I welcome you all to our Little's Law YouTube channel. So today, in this video, we're going to see about the thread dump. So I'm going to take you through a real example of how to analyze the thread dump, and in fact, in most of the scenarios where if you do not have an APM, an application performance monitoring tool to monitor the performance bottlenecks, in those scenarios, these visual VM tool, any kind of profiler, so these tools will help you to bifurcate or to do a deeper analysis on the various threads, on the various processes that's running during a load test, and to check on your performance bottlenecks, like if there are any threads that are like waiting or runnable, and if some threads are running, so what amount of CPU do they consume. So and in fact, more about the garbage collection as well. So if you have practiced yourself on doing the thread dump analysis, it will be definitely helpful for you in your interviews, and also once you join the organization, it will definitely help you to fix the performance bottlenecks, because no more the performance testers are needed. In every organization they need performance engineers, and this is a good chance for you to learn these techniques and move forward as a performance engineer. So, with no further ado, let's go to the video. And this is me, Vasan Shanmugam. I welcome you all to a Little Sly YouTube channel. Please don't forget to subscribe to our channel. If you haven't subscribed yet, share the video with your friends. And if some of your friends who wanted to get a good career option, or they want to move to performance testing or engineering, please do share our link to him for subscription and to learn more. So now let's see. So this is again, it's a thread dump that's taken while I was running an Apache JMeter. So this is completely a Java-based thread dump analysis. In fact, we will see about various uh, thread dumps in our upcoming videos. But in this video, I will take you through this thread dump, and I will explain you what is happening, and how to understand the issue, and how to give you the solution for this thread dump. Okay, so firstly we will check this part here, which is the full thread dump Java hotspot 64-bit Java server. So this is a thread dump from a Java application which is running on the Java hotspot 64-bit server VM. So the thread dump provides information about all the threads which are currently active during the thread dump time. So it's not now, they're active during the time when we have taken the thread dump snapshot. So each line in the thread dump represents a single thread along with its state and any other relevant information. So here it starts with the timestamps at what time we did take this thread dump, and then the Java virtual machine which we used for the thread dump, and then we have got a different set of information, which is the Java thread list, and then the thread class SMR info. So this section mostly provides information about threads in the JVM, and each thread is represented by a hexadecimal memory address. If you can see here, they come up with the hexadecimal memory address, and there is a list of these addresses along with their respective lengths and elements, right? So each thread in this list represents a separate execution context within the Java application, and the information provided typically includes the thread's state, its stack trace, and other diagnostic information, which will be useful for you while you want to debug and for any performance analysis. So now let's move on to the next part of it, which is the runnable. So the second part here is the runnable. In fact, if you have not watched my video on the life cycle of a thread, I have explained on each state, which is starts from the new, the waiting, the runnable, the terminated, the blocked, and everything. But in real scenario, so this is how we can see the state of each thread. So in this part, which is the java.lang thread, the runnable. So it starts with the reference handler. So if you can see here, so let me first give an idea on this part here. So the thread name is reference handler, which is the name of the thread, and the thread ID is number 8, which is the unique identifier for this thread, because if you can see here, this reference handler is number 8, and then we have got the finalizer as 9, the signal dispatcher as 10. So this is something which is a unique identifier. And then we have got the daemon priority. So this indicates that this thread is a daemon thread with a priority of 10, and then we have got this one as a daemon priority of number 8. This is under 9, and then this is under 5. So same way, the daemon priority will change and it will be different for every threads. And then we have got the OS priority. So in this case, this has got 2 as its priority. So it's just basically the operating system priority. And then we have got the CPU time. So in this case, at least for this thread, it's 0.00 milliseconds. The elapsed time here is 136.06 seconds, which indicates the elapsed time since the thread was started. So this has started before 136 seconds and it's still running. Yes, and this one, the thread ID, it shows that it's a native thread ID. And apart from that, there's some other information which we wanted to know is the java.lang.thread.state is runnable. This indicates that the thread is in a runnable state, meaning it's actively executing the code. And then the stack trace. So that stack trace provides information about what the thread is currently doing. So in this case, the thread is executing methods related to managing references and handling pending references. So the first line, if you see, java.lang.ref.reference wait for reference reading list, reference pending list is a native method, and it's also executing methods with lang.ref.reference and lang.ref.reference for the process pending reference, and then the reference handler. And then finally the logged ownable synchronizer. So this section, in fact, this section is like for every thread. So if you can see it's been part of every thread group, so it's a kind of a template one. So this logged ownable synchronizer indicates that any synchronizers that the thread currently holds. So in this case, it shows that there are no logged ownable synchronizers held by this thread. So overall, this particular thread, the reference handler number 8, is responsible for managing references and cleaning up objects that are no longer in use, and it's currently in a runnable state, and it is actively processing the pending references. So let's now move on to the next thread. So next thread is the waiting. So let me explain what does this waiting tells you. So this particular thread group, so let me just go directly to the state of it, because we have discussed this in the previous thread. It's again the same thing. It goes with the same priority and the elapsed time and everything. So when it comes to the state, it's waiting and it's on object monitor, which indicates that the thread is currently in a waiting state. So the previous one, it's in a runnable state, and this thread, it's in a waiting state, which is waiting on a lock, which is specifically waiting for an object monitor. So if you see, it's waiting on an object monitor, and this is waiting on a lock actually, so which is held by an object, and it's likely related to the finalization process. So how do I know that? Because if you see, when you go through these lines, you can see that it's waiting for the finalizer thread. And if you can see here, yeah, this part, the locked, so this is basically waiting, and here it's locked by the native reference queue. So that is the key point which you all need to know. So the thread is locked on a lock which is held by 00, the 7EB050, the hexadecimal reference, right? And this section indicates that the thread holds a lock on a specific object which is related to the finalization process. So by understanding these key metrics or the key values, you would definitely help the team to resolve the issue. So in this case, you can come up with the analysis point that the finalizer thread, which is this thread, is responsible for performing finalization of objects, which involves cleaning up of resources before the objects are garbage collected. So in this thread dump, the finalizer thread is waiting, is in a waiting state, which is waiting for objects to be enqueued which you can see here, just like enqueued. In the reference queue for finalization. So it's specifically waiting on a lock related to the finalization process, and this behavior is normal and indicates that the finalization process is ongoing. However, if the thread remains in this state for an extended period, because it's waiting, but if it extends, or if there are a large number of objects waiting for finalization, it could indicate a potential performance issue or a bottleneck in the finalization process that you may need further investigation. The reason I'm taking you through each and every minute details is you can use this in an interview. You can tell them that this is how you have identified, or you did the analysis for a thread dump, and you have come up with a analysis way or analysis part, right? And let's now move on to the next thread. And if you can see these threads, so they are like almost common, so they are all runnable threads, but they are all waiting on a condition, and they stays the same, because when it comes to the hexadecimal value, if you can see here, they all wait on a condition, which is this particular condition. And they are since in fact, like, they don't own any synchronizers, that they are not locked, but still they are waiting for a condition. So if this particular waiting exceeds, as we have already seen, if it's exceed, then it can lead to a performance bottleneck. And now let's move on to these two threads. So if you see, the reason I am taking these two threads are again the same scenario, because the CPU is more than 2 seconds, and it's more than 1 second for this particular thread, and in fact they are runnable, but they're waiting on this condition here, and the elapsed time is like more than 2 minutes. So this part actually tells us that both the compiler, so these both are like compiler threads, they are in a runnable state, which indicates they are actively processing some compilation tasks, but the CPU time for both these threads is relatively high, because when you compare it with the other threads, they were like less than 100 milliseconds, but this is actually more than 2 seconds, which is quite high. And this suggests that there is some significant CPU resources are being allocated to compilation tasks, which could actually impact the overall performance of the application. And the elapsed time, again we saw, it's indicating that it's running for a considerable amount of time, and both these threads are daemon threads with a priority of 9. So if you can see, they were both on 9, but in fact all the other these priorities as well are like in 9, indicating that they are low priority background threads. So that could be another reason where it's uh, been waiting. And there are no compile tasks currently assigned to either thread, which means they are idle and they are waiting for tasks to process, which I have already told you in the beginning. So since there are no compilation tasks currently to the thread, so if you see, there are like no compilation tasks, but still they are idle and waiting for the task to process. So that's why it's runnable, but they are waiting on a condition, right? And then let's now move on to the next thread. So here the previous, so okay, again, when it comes to the another thread, so previously we saw about waiting, we saw about runnable, and now this is another set of thread, a life cycle in the thread that comes in like the timed waiting. So what is this timed waiting parking tells us about? So here the common cleaner, so let me first tell you about this common cleaner. So this common cleaner thread is part of the Java reference handling mechanism, which is responsible for performing cleanup actions on objects when they are no longer reachable. So it's currently in a waiting state, which is timed waiting state, which is waiting for references to be enqueued. So if you see the waiting on condition, which is waiting for this particular hexadecimal value, which is for another task to be enqueued for cleanup. So this is a normal and expected behavior, and it indicates that the cleaner thread is idle based on the metrics it gives us, and it's like parking to wait for the logs, which is given here. Since it's a daemon thread, it runs in the background and it helps manage resource efficiently. So this thread presence, so actually this thread's presence and behavior do not indicate any issues with the application, but it's performing its intended task of cleaning up resources as needed. So Let me tell you one more thing. So the daemon priority, when it comes to daemon priority, what does this 1, 2, 3, 4, 5 till 9? So the number, when the number increases here, which is like, if, okay, let me tell you the other way. Like if it is 1, it's high prioritized, and when it is 8 or 9, it's like low priority. So based on the number, so the lesser the number, the priority is high, and that's for the daemon priority. And the next part, okay, so this is again a timed waiting, which we all know. I have discussed this about in the previous video on the life cycle. So when it is like timed waiting, which means like it is waiting for some particular amount of time, and it again process once the previous process gives the signal to process. So again, like this is waiting for the cleaner action to be completed. So it's obviously it's a uh, timed waiting process. And all the other threads which are like similar, almost similar like this. And then let me take you through another important one, which is the so here if you see, we have got the waiting parking, because previously I have explained you about on object monitor, but let me explain you about the waiting parking. So what's the difference? Because we all know about the life cycle of a thread. It does the waiting, but there are again like differences here. What does this waiting parking is all about, and what does it means about on object monitor? So let me explain you about that. So when it comes to the AWT event queue, so this is an integral part of the Java AWT event handling system, and this is actually responsible for processing and dispatching user interface events, right? And its current state is waiting, which indicates that it's idle and waiting for the next event to be available in the event queue. And this is a normal and expected behavior for event driven applications. And it does not indicate any issue with the application as long as the AWT event queue continues to function properly and events are processed efficiently. The behavior of this thread is considered normal. And even if you see, uh, the daemon priority is like 6, which is bit less. I mean, like I would say it's not like high prioritized one, but it's waiting on a condition, and it's, as I told you, it's waiting on a parking condition. So the difference, what's the difference between waiting parking and waiting on object monitor? So basically, when a thread is in a waiting parking, it means that it is waiting for a specific condition to occur. So this condition can be anything that the thread needs to be proceed, such as a lock or a signal or a specific event, right? But what about object monitor? What does this means? So there are like waiting, I understand. What is the difference between parking and object monitor? So when it comes to object monitor, it means that it is waiting for another thread to release a lock on a specific object's monitor, right? So let me explain it again. So when it comes to parking, it means that it's waiting for a specific condition to occur. But when it's come to waiting on object monitor, it means that it's waiting for another thread to release a lock on a specific object's monitor. So when it comes to waiting on object monitor, this happens when the thread calls object.wait, or when it tries to enter a synchronized block or method. So that's all about the waiting parking. And then at the end, if you see, we have got several other threads. So in fact, almost like everything is same. We have got runnable threads, we have got the daemon priority. So if it's like 5, yeah, it's closer to a higher priority. And so when it comes to the other threads at the end, so why does it does not give a stack trace? They come up without any stack trace, but they have a name, they have a priority, they have a CPU time, they have elapsed time, they have their own hexadecimal ID, and then they all shows that they are runnable. And I think one of it is waiting. Yeah, this is waiting on a condition. So let me explain you it. Just let me give you a summary of all these, like what do they do. So these thread dump shows various threads which are related to garbage collection. So just this GC, anything that starts with GC, they are like garbage collection related threads, and other VM tasks. So on the top there is a VM task, and here you can see a VM task. So the threads are in different states, such as runnable and waiting, and perform different roles, which includes garbage collection, marking, concurrent tasks. So they are like doing various different tasks, and these are necessary for the proper functioning of the JVM and for any memory management in the Java application. Okay. let me give you another perspective of understanding this. Okay. Uh, so since we have seen multiple threads, so the presence of multiple garbage collection threads and VM related threads in the thread dump does not necessarily indicate a performance bottleneck, but certain observations will give you a hint on a performance issue. So let me give you a few examples. Like, what if the values in this thread dump are higher or lower? Okay, so let me first take you through the CPU time. So if the CPU time consumed by the GC threads or VM related threads is consistently high, it could indicate that a significant portion of the CPU resources is dedicated to garbage collection and VM maintenance tasks, and this might lead to increased application pass times and decreased overall application performance. That is how the high CPU type comes in. And then the long elapsed time. So if the elapsed time for GC threads, so if you see the elapsed time here, so if this time or the VM related thread is excessively long, it means that these threads are taking longer than expected to complete their task, and the prolonged execution time will result in increased response time. So we all might know how does this response time gets increases, right? So if this elapsed time increases, automatically the response times increases and it degrades the application's performance. And then the waiting threads. So if you see at the bottom, we could see some of the waiting threads. So if any of these threads are in a waiting state for an extended period, it might indicate contention for resources, which means like the resources will get smaller and smaller because they are keeping on waiting, and this could potentially lead to performance bottlenecks if multiple threads are competing for the same resources, because the moment they starts to wait, automatically there will be a competition that will be started, that will be like automatically gets created, and when multiple threads starts to compete, there will be a performance bottleneck. And then finally the JNI global ref and weak references. So the count of JNI global references and weak references can also provide insights into memory management and potential performance issues. So a high number of JNI global references or weak references might indicate insufficient memory usage or potential memory leaks, which can impact the application performance over time. With that, we come to an end of this video. So in this video, I have taken you through a thread dump and I have explained you about the various thread states, and I believe this video would be very useful to you. So until I meet you in another interesting video, it's bye bye from Vasan Shanmugam and your favorite little slaw.